Hello everybody, Root Beer here, looking at question number 4 on the 2010 Grade 12 Manitoba Math Contest. So question 4, if you haven't tried it already, I do encourage you to download a copy of this contest, first link in the description, try it for yourself, try the rest of the questions too. Question 4, 4A. Two semicircles, as shown, have center O. Okay, so they're concentric semicircles. Points A, B, O, C, and D are collinear, and both A, B, and C, D are 1. Alright, the shaded area is 15 pi, find the length of AD. So that's akin to finding the diameter of the big semicircle. Okay. So, basically, we're finding this area here. And it's a big semicircle with a smaller semicircle cut out. So we have A, B, C, D. Okay. So AD, let's let that be 2R. R here is the radius of the big semicircle. And let's let BC be 2 little r, where r here is the radius of the little semicircle. Okay, so the shaded area is really the big semicircle. 15 pi is shaded area, but we can recognize that as the big semicircle's area. So that's 1/2 pi r squared minus 1/2 pi little r squared. Okay, so now we've got an equation involving the r that we want. We want 2r in the end, 2 capital R. But what are we to do now? We've got an equation involving it, but we also have this little r here. So we've got one equation, 2 unknowns. That never bodes well. Well, they gave us extra information. AB plus BC plus CD is AD because they lie on a line. Now those two are 1s, and this we said is 2 little r. So now I can see capital R is just r plus 1. Okay? Or alternatively, little r is capital R minus 1. So I can do 15 pi is, well, let's multiply by 2 and divide by pi on both sides, we'll get 30 is capital R squared minus capital R minus 1 squared. Okay. So that's capital R squared minus capital R squared minus 2R plus 1. So the capital R's cancel out. We're left with negative of negative, so 2R minus 1. R is going to be 31 over 2. And therefore 2R, which is equal to AD, is going to be 31. Okay, not bad at all. So 31, that's going to be the answer that they were asking for, and we've explained how things go together to find that. Okay, B part. Consider a circle and a square whose areas are equal and which have the same center of symmetry. Okay, so they both have the same center. If the radius of the circle is 2, find the length of AB. Express your answer in terms of pi. Okay. So radius of the circle is 2. Alrighty. So what can we do? Well, let's draw a picture. That's too close to the edge. It's also a little big, too. Circle. That's not a bad circle. And we got our square here. So they said they have the same center of symmetry, and they have the same area. So one thing I want to do is put in this center. They bothered to talk about it, so let's get it in there. We've got AB, and we want the length AB. in terms of pi. So now the areas, well, let's call the area of the square s. So s squared has got to be the same as pi r squared, but we know r is 2. So that's 4 pi. So s is going to be 2 root pi. That's the side length of our square here. Now they bothered to give us this information, so we might as well use it. Now, what can we do? Well, I notice A and B are both on the square and the circle. So I'm going to drop 2's here. And I suppose I can draw this perpendicular line through here. But a line through the radius that's perpendicular, or sorry, a line through a chord that is a radius that is perpendicular splits this thing in half. So I might call that point C or something like that. So AB is AC plus CB, and that's really just 2AC. Okay, AC is equal to CB. Okay, but I know that, we'll call this O. OC has a length a half of S, so it's just going to be root pi. Root pi in here. And by Pythagoras, so by Pythagoras' theorem, or by the Pythagorean theorem, we know that OA squared is AC squared plus OC squared. That's 2 squared is equal to AC squared plus root pi squared. So that's 4 is AC squared plus pi. So AC squared is 4 minus pi. AC is the square root of 4 minus pi. That's as easy as we can write that. And that tells me that AB, the length we're searching for, is 2 times 4 minus pi. I suppose if you wanted to, you could bring the 2 inside and make it 16 minus 4 pi. But I think either one is fine. Frankly, I'd prefer the 2 outside if it were me marking. But, you know, some people like putting everything under the square root sign. That's okay. But we have everything expressed in terms of pi. Square root of 16 minus 4 pi. That's a fantastic way to do it. All right, so that wraps up question number 4. I really liked that second question. I think that's nifty. I wonder what you could do if you had a regular pentagon or a regular hexagon. There's lots of things. Whenever I finish a really good question, I like to occasionally just sort of say, well, what if I changed this aspect? What if we changed the square to a pentagon or hexagon or just a regular old n-gon, and let A and B be intersection points of the circle and that regular n-gon that are close? I wonder if there's a general formula for that. Oh well. If you want to try that question and find a good answer for me, by all means, leave a comment down below. But either way, I will see you guys for question number 5 in the next video.